Okay, guys, here's our last set of problems. Number 19, this is the back. We need to find the derivative of the function secant of the square root of t. Okay? Now, I know the parentheses aren't in the problem, but you really should be thinking that we're taking secant of whatever the square root of t is. So really what I have is a chain rule problem here. I'm really taking secant of t to the 1/2, right? So if I'm going to take the derivative... Ooh, wow, that looked really silly. I'm sorry. The derivative of the outside secant is secant tan. So secant tan, right? But what was plugged into those? The square root of t was. Okay. So I took the derivative of the outside, I plugged in the inside. Now I have to multiply by the derivative of what I plugged in, the square root of t. So I'm going to take down the 1/2. This is going to go to the negative 1/2. So if I were to rewrite this, I'm going to have secant of the square root of t. I'm going to have tangent of the square root of t. That 2 is in the denominator because of that 1/2. This goes to the denominator because of the negative, so that's going to be 1 over t to the 1/2. Well, t to the 1/2 is just the square root of t. So that would give you answer choice D, it looks like. So let's do the next one. Number 20. My function is y equals x over cosine squared x plus sine squared x. So now we want to figure out what y prime is. Well, hopefully, if you could remember one trig identity for this test, you should remember that cosine squared plus sine squared is equal to 1. So y is really just x, which means that the derivative of y is just the derivative of x, which is just 1. Which is answer choice B. Now, I'm sure you can go through the long way and do down d up minus up d down over down down. But I would just do this. Okay, number 21. We want to find the derivative of sine squared of x cubed. Well, if we want to rewrite this, really what we have is sine of x cubed. And we're squaring all of that. So notice this layer has 3 pieces. My most outside piece is this. Okay. My next piece is this. And then my very inside is x cubed. So it's kind of like those layering dolls, right? We can have layers upon layers, so n sine and x cubed. So if I want to take the derivative of this, I'm going to take the derivative of the outside, which says 2 stuff raised to the first. Well, my stuff is sine of x cubed. Well, whatever stuff I plug in, I take the derivative of. So we need to take the derivative of this. Well, this is also going to be a chain rule, right? So the derivative of the outside portion, sine, is going to be cosine. But I have to plug in the stuff. Well, whenever I plug in stuff, I take the derivative of the stuff. Well, the derivative of this stuff is going to be this. Okay, so now we're going to simplify that as best we can. I'm going to combine that 2 and that 3 and get 6. X squared, sine of x cubed, cosine of x cubed. Now, I have a personal habit that I like to put parentheses around whatever my argument is. Notice I did it up here too. Not everybody does that, but I do that. I just find it helpful. I think it makes it more clear what is inside the argument of sine. So something you might just want to make a habit of doing. Okay, number 22. We want to find the limit or evaluate the limit as h approaches 0 of secant of x plus h minus secant of x all over h. Well, hopefully you're looking at this and saying, wait, this is limit definition of a derivative, right? Because I plug in, I have my function evaluated as x plus h minus my function over h. So that means my function here is secant of x. We're not evaluating at any given point, but all it's really asking us to do is evaluate this. Well, if we evaluate this, we're going to get the derivative of the function, which is secant. So what's the derivative of the function? The derivative of secant is secant x tan x. And that's my answer. That's it, evaluated. Okay, let's move on. Let's finally box these before we go. Okay, number 23. We want to evaluate the limit as h approaches 0. Sorry, it's going to be a little fast. Of two plus h cubed minus 2 plus h squared minus 4 all over h. You'll notice I took my bracket down just a little too far. So again, let's think about what's happening. This is the limit definition of a derivative. We have the function evaluated at something plus h, then we have the function, and then we're dividing by h. But in this case, rather than having x, you'll notice we see numbers instead. So this is actually being evaluated at a certain x value. So let's see if we can identify what the function is. Well, notice we are going to plug in x plus h into whatever our function is. So x plus h, it looks like 2 is our x, is being cubed. Then it looks like x, or the thing that we're plugging in, is getting squared. So I think that's my function. It also looks like I'm evaluating it at an x value of 2. Well, let's see if I plug in 2 if I get 4. That's going to be 8 minus 4. Yep, that gives me 4. This looks good. So what they really want is to evaluate this. We're evaluating the derivative of this at 2. The derivative of f of x is 3x squared. And we want to evaluate it specifically at 2. Wow, so 12 minus 4, which is 8. Okay. Now, you probably could evaluate this using limit rules, but this would be the faster, quicker way to do the problem. Okay, we got, it looks like one more that's got parts. 24. We're going to be answering questions. I'm not going to write the table on here. You've got it on your paper. So let's do part A first. We're taking, we want h prime of 3. Well, h of x is this. Okay, which means my derivative is the first times the derivative of the second, second times the derivative of the first, oops, f. Okay, we're evaluating it at 3, so we're going to have f of 3, g prime of 3, g of 3, f prime of 3. Well, f of 3 is 3. G prime of 3 is negative 2. G of 3 is negative 1. F prime of 3 is 5. So it looks like I have negative 5 minus 5, so we have a good old negative 10. Oh, sorry, I'm being silly. This is 6. Negative 11. Okay. Why don't we do one more together? Well, let's see how much we can fit in. Let's do B. H of x is f of x over g of x. We want to find h prime of 2. So my derivative is going to be down, d up, minus up, d down, over down, down. Well, we want to figure this out at h prime of 2, so an x value of 2. So that's going to be g of 2, f prime of 2, f of 2, g prime of over g of 2, 3 squared. Okay, well that's going to give us 6. Why did I write this time? Minus a minus 2, so plus 2 over 9. Looks like 8/9. Okay, we'll keep it. Why not? I'm sorry, some of you might need to look at that real fast. Okay. C. We're almost done. Okay, we've got h of x is equal to f of g of x. Well, if I want to take the derivative, this is a chain rule, so I take the derivative of the outside, plug in the inside, times the derivative of the whatever I plugged into the inside, so g prime of x. Okay, so if we want h prime of 1, f prime of g of 1 times g prime of 1. Well, g of 1 is 2. G prime of 1 is 1. F prime of 2 is 2. So it looks like I got a grand old total of 2. Okay, guys, this is our last problem. We can do it. So we got h of x equals f of x, g of x. Write the equation of the tangent line and normal line at x equals 2. Okay, so if we're at x equals 2, let's start by just figuring out what the point is. We're going to be at 2 comma, well, we want h of x, right? So h of 2 is going to be f of 2 times g of 2. So f of 2 is 4. G of 2 is 3. So if I multiply this together, I'm going to get 12 as my point. So again, remember this thing here was h of 2, which was equal to f of 2 times g of 2. Okay. If I want my tangent line, I need to know what the derivative is. I want my derivative at 2. Okay, f is 4. G prime of 2 is negative 1/2. G of 2 is 3. F prime of 2 is 2. That's going to give us a negative 2 plus 6, the slope of 4. So my tangent line is going to be at y minus the y coordinate, the slope of the tangent line times x minus the x coordinate. And my normal line is perpendicular to the tangent line, which really just means that the slope is going to be the negative reciprocal. Okay? And that is our last problem. Let me just remind you guys one more thing. If you need to do point slope form of a line, it's y minus y1, slope x minus x1. There you go. You guys are going to do great, and I'll see you guys on Friday.